Welcome back to Building Games on AWS. In this series, we'll show you the simplest way to integrate Amazon GameLift with Unreal Engine 4. In this episode, we'll go over how to make REST API calls from a user widget in our game client to Amazon API Gateway. We will then create a widget blueprint which will serve as our login menu in the offline map. The first thing we have to do is to create some new C++ classes. So navigate to your Unreal project folder, open your project, and open the editor. The first C++ class we're going to make is a new game mode, because most likely you would not want to have the same game mode for your offline maps or your main menu as the same as the online server map. So I'll name this offline game mode. It will automatically open up Visual Studio and load that new game mode file. Back in the editor, we're in the offline map, and in the world settings, if you don't have this window open, go ahead and click on Window and select World Settings. And for the game mode override, go ahead and select the offline game mode for the offline map. The second C++ class that we will add is the user widget. Now, for this to show, you have to click the checkbox Show All Classes, and you have to type in user widget. And I'll name this offline main menu widget. In Visual Studio, open up your GameLift-UE4.build.cs file, and here there are a few modules we need to add to the project. So we'll need HTTP, JSON, and JSON utilities. You can go ahead and save and close out of your build.cs. Now the first thing we want to do is define our offline game mode. So for this project, the offline map also uses the third-person character. So we can actually copy over some of the default script to set the default pawn class for the offline map. But first, head over to the offline game mode header file and define the constructor. Then we can open the GameLift-UE4 game mode CPP file and copy that default pawn class script. Notice that we are using constructor helpers, so we also need to copy over that include statement, and as well as the include statement for the third person character. Now that is done, we can go ahead and save all and close out of the offline game mode and the offline game mode header. go ahead and close out of the GameLift-UE4 game mode as well. Now we're ready to work in our offline main menu widget code. The first thing we have to do is include the HTTP header. Then we can declare our U functions and U properties. But first, we have to declare our constructor. So the constructor for a user widget is offline main menu widget and takes in an F object initializer. Next, we want a U function called onLoginClicked, and we want that to be blueprint callable. So this is the function that will get triggered when a player clicks the login button. Now, the next three U properties are for the API gateway endpoint, the login URI, and the start session URI. And we want that to be edit anywhere, so that later on, when you have to change your API gateway endpoint or any of the URIs, you can do so in the widget blueprint. And then for the next U properties, it'll be the user and pass for the username and password. And we want that to be blueprint read and write. And the reason for this is the widget blueprint will take in what our player input in the input text field and assign it to these variables, the username and password. And we'll take the username and password and to pass it to our API calls as a JSON body. So now we're ready to declare our private variables and functions. The first one we want is the HTTP module, and we can do that by fHTTP module asterisk, and we'll name it HTTP. The first private function we want is the login request, which coincidentally take in the username and password. So the way it works is when a player clicks the login button, onLoginClick will be called, which will call login request. And in this login request, we will make an API call to Amazon API Gateway, which passed the username and password to the Lambda function. And after, we will get a login response. And in this login response, we'll handle that response. The main thing we want from there is an ID token. So once we get that ID token, we can initiate our start session request, which is the second API call. So it takes in an IDT, that stands for ID token. And from this start session API call, we will get the start session response. And this response is a JSON object with all of the GameLift data that the client needs to connect to the GameLift server, namely the IP address and the port number. Now to code out the C++ file, The header files that we need are json.h and jsonutilities.h. These were the modules that we previously included in our build.cs file. And furthermore, we will also need the game statistics header file. And we will use this when we connect the client to the server. So the first function we need is the constructor. And in the constructor, we want to initialize the HTTP module. We also want to initialize our API gateway endpoint and the login URI and the start session URI. So for a quick refresher on how to get your API gateway endpoint, we'll go over to the AWS Management Console. After you log in, you can click on the Services dropdown. You can find API Gateway under Networking and Content Delivery, or you can type API Gateway, and it should be the first service that shows up. And click on your backend. And on the left side, left-hand navigation, we want to click on Stages. So this stage should be our testing. So you click on the name of the stage, you'll find that invoke URL, and that's our API gateway endpoint. Back in Visual Studio, your login URI and your start session URI should be /login and /start session if you have been following along with the tutorial series. The next function we want is the onLogin clicked. And this one is as simple as calling the login request. And it passes those 2U properties that were blueprint read and writable, or blueprint read and write. And we will assign this in the widget blueprint itself. Then it will be the actual login request. This is where we'll handle the API request for login. So to send the username and password as part of the API call, we need to create a JSON object. And the way to do that is tshared ptr fJSON object in carets. We'll name it JSON object equals make shareable new fJSON object. So to add the username and the password to our JSON object, we need JSON object dash arrow, or the right caret key, set string field, username, then f-string printf, and it points to the username that was passed into this function. And the username here is the key for that JSON object. And this is dependent on what your Lambda functions takes in. So the key will be username, and the value will be what the player input in the widget blueprint. Same for the password. Now we have to serialize our JSON object. And to do that, we need a JSON body f-string and a JSON writer. So for the JSON writer, it'll be t_ref, t_JSON writer, t_char in carets, and we'll name it JSON writer, equals t_JSON write factory, and create. It points to the JSON body, or reference the JSON body. To actually serialize our JSON body, we need fjson serializer, serialize, JSON object dot t_ref, JSON writer. After we got our JSON payload, we need to make the actual HTTP call. So to do that, we need t_ref I HTTP request in thread safe mode. We'll call it login HTTP request, and we'll use the HTTP module to create the request. And next, we have to essentially define the parameters for the request. So it'll be login HTTP request, arrow set verb, and it'll be post request. And for the URL, it'll be set URL, the API gateway endpoint, plus the login URI. For the header, we want content type as application JSON. And for our payload, we want the JSON body to be the payload. It'll be set content as string JSON body. Then once this request is complete, we want to call on login response, essentially a function to handle the response from this request. So login HTTP request arrow on process request complete, bind object this, and it references on login response, which we will code out next. Finally, after all your parameters are defined for the request, we want to go ahead and process that request. So login HTTP request arrow process request. Now we can create our on login response. So on login response, it takes a request pointer, a response pointer, and a Boolean whether the request was successful or not. The first check we want is if it was successful. And if it is, we want to create a JSON object to store the response. We'll also need a reader to parse out the content of the response. So it'll be teach share ref, t JSON reader, we'll name it reader, t JSON reader factory, create, and we'll get the response from the HTTP request, arrow set content as string. So once we got our object and our reader, we need to deserialize that JSON object. And we only want to do so if there is something to deserialize. That's why this is there. This if statement is there to do that check. So if there's something to deserialize, we'll go ahead and do that. And from that, we want the ID token. So the JSON object that we receive as a response will be a nested JSON object. And the way we read from a nested JSON object is to first get the object field of the object with nested objects. And the field that we want is the ID token. So perhaps it's best if I show the response from the login request. Here we are in the AWS Management Console. To get to the Lambda console, drop down on the services and under Compute, click on Lambda. And the function, the Lambda function that we had connected to our login API is the Cognito login. So I'll quickly test that. You can see from the results that what we have as a response is a nested JSON object. So the first object is status, success, but the one we're interested in is token, and nested within tokens is ID token. And this is what we want to parse out. So that's why back in Visual Studio, we want get object field tokens, and then from there get string field ID token. Once we have the ID token, we want to start session request or initiate that API request for start session. Next, we can code out the actual start session request. What we need to do here is create another HTTP request similar to our login request. Teach@ref I HTTP request thread safe. We'll name it start session HTTP request, and we'll use the HTTP module to create the request. Now for the parameters, instead of a post request, this time it's a get request. The start session URL will set that URL to API gateway endpoint plus the start session URI. The first header is the same, content type application JSON. However, there's an additional header with the key authorization, and we'll pass in the ID token. Now this ID token will authorize the player with using our Cognito authorizer, which links to the Cognito user pool. Once that request is complete, we want to call on session response. So after all the parameters are set, we'll go ahead and process that request. For our final function, we want on start session response. Now, this is to handle the response from the start session request. Similar to on login request, we want to make sure it was successful. If it is successful, we want a JSON object to store the JSON response. And similarly, we'll once again need a JSON reader. So we have our object and our reader. We have to check if there's something to deserialize. And in the same way that we got the ID token, we want to get the IP address from this response, as well as the port number. Notice how it's get object field player session, it gets string field IP address, and then it gets string field port. So let's go back to Lambda console and take a look at that response. Okay, so here we are back in the Lambda console. We want to go back to our functions. And the one that's tied to start session API call is the start GameLift session. So let's quickly test that, and we can see the response. And this is the response from GameLift service. So there are two nested JSON objects here. The one we want is player session, and in player session, we want the IP address and the port number. In the future, should you require other data from this response, uh, we will get it in a similar fashion. Uh, you might need player session ID, player ID, game session ID, fleet ID, or fleet ARN. But for now, we'll just stick with IP address and port number. Back in Visual Studio, that's why our JSON object, arrow, get object field, player session, and make sure you use the proper case as well. So capital P, player, capital S, session, get string field, capital P, port. So now we have the IP address and port number from GameLift. So from the IP address number and port, we want to make a level name. So fstring level name equals IP address plus colon in parentheses plus port. So finally, all of these API calls, all of these functions, all of these response handling is to arrive at this point. So this API call open level will connect the client to the GameLift server. So we want uGameplay status colon open world get world f name, that's the name of the level which we concatenated with the IP address and port number, And for now, we'll set this to false. That's it for our offline main menu widget C++. Go ahead and save your project and build it while you're in Visual Studio. Okay, the included file, H file, should always be the last in the included header. Okay, let's quickly fix that. So we have to move R in the header file. We have to move the HTTP to the top. Once back in the UE4 editor, navigate to your blueprint folder, and we want to create a widget blueprint. So right-click, select user interface, and create a widget blueprint. And we'll prefix it with WBP underscore offline main menu. So before we forget later, we want to go into the level blueprint. So click on blueprint at the top of the editor and open level blueprint. And we're here to create the widget and add it to the viewport. So on event begin play, create widget, and that will be our WBP offline main menu. Then we'll add it to the viewport. Also connect the target. Compile and save. Then we can close out of the level blueprint. So now open up the widget blueprint. What we want to do here is to create a very simple UI where the player can enter their username and password and click a login button. So the first thing we need is a panel. And the easiest one to use is the vertical box. So drag and drop the vertical box into your canvas. Then we're going to need a couple of text boxes inside the vertical box, one for the username and one for the password, or essentially labels. So the player knows which text field to input what. Then for the input, we want the editable text. One for username and one for password. And finally, we need a button, which will be our login button. So for our login menu, I like to keep it on the bottom to the right so it doesn't block the player. Um, if you don't have uh, the player running around in the offline map or in your lobby, feel free to put it in the center. So open up or drop down the anchors and hold down Shift Control to move the vertical box canvas. I'll put it in the lower right hand corner. So that I'll minus it by 50, or the size X 300, size Y 500. That might be a bit too much, so 400. Okay, so our first text block, we want to change the text to username. And for the second text block, we'll change that to password. Now for the editable text, we want to change the suffix so we can, so it's more clear which one is which. And make sure that is variable is checked. Editable text underscore path is variable is checked. And for the button, we want the text on there to say login. So we need to add a text box. Let's add some padding to this. And let's make the font size 18. You can probably resize the content so the size Y is not as high. So compile. Now let's take a quick preview to see what it looks like. Here we have username, password, and login button, which right now does nothing. Back in our widget blueprint, let's rename that button with the suffix login to avoid confusion later on, and make sure that is variable is checked. So in the details pane, scroll down to events, and where it says on click, click the green plus button. This will take us over to the graph. So what do we want to do when a user clicks the login button? Well, we want to take whatever they input in the editable text field and assign it to our user and pass variable. So how do we do that? Let's pull out from onClicked button, and we want to set user. And so if you don't see your variables here, um, the reason is because you haven't reparent the blueprint. So we have to reparent this widget blueprint to the one that we just finished coding out. So file, reparent, and we want the offline main menu widget. So if you click class defaults at the top, you'll be able to see the edit anywhere U properties, namely our API gateway endpoint, login URI, and start session URI. Should you need to change this endpoint later, this is where you would go and do so. So when you pull the pin out from onClicked and we want to set user, that variable is now visible to us. Uh, and what do we want to set this to? The text input. So get text user. The node we want here is get text. And the return value, put that in the return or the input value for set. Then we want to do the same thing for the pass variable, for our password. Editable text pass, get text, the return value into set pass. So what happens after we set the username and password? Well, we want to make our API calls. So from there, we want on login clicked. And in login clicked, we'll call login request. Then we'll handle the response with on login response. We'll call the start session request and then handle the response from start session, which will also connect the client to the GameLift server. So this is all we need in the blueprint for our widget blueprint. Let's go ahead and compile and save. And now we're ready to test play. So put in a username and password that you had in your Cognito user pool and click login. And here we are in the GameLift-UE4 server. Now we're going to take a moment to celebrate. And that'll be it for this episode of building games on AWS. In the next episode, we'll go over the next steps in your Amazon GameLift and Unreal Engine journey.